No, I swear to you.
Remember to grab your handouts up front. You need to come get them. Also, I think there's one assignment I'm asking you to turn in here to start a class. So, if you want to, you can put it in the basket by my computer right now before it gets busier. You can wait till 5:30. All right, good morning, guys. Make sure you look over at the bell work here during the minute of silence so that you'll be ready to go. Here. Simon's absent, Lauren's late.
Thank you very much. Will you please stand and hold for the pledge? Flag of the United States of America,
The republic for which it stands, one nation under God,
indivisible, with liberty and justice for all.
Sorry, some days our speakers don't work and some days they do, so sometimes it's hard to hear the pledge in the middle of the silence. But okay, so bell work, make sure your phones, earpods, smartwatches, all that stuff's put away, obviously. We need you to get out number 4 and number 7 from your binder. Number 7 is a handout that you picked up last class, but we didn't start on it yet. It's one of the 2 things we're going to look at today. And then number 4, I gave you some class time last time, and then what you didn't get to was homework. So, any other assignment numbers 4s, make sure your name's on them, and I need those right now if you haven't turned those in. Now, if you turned yours in the Google Classroom, that's fine too. You don't have to give me hard copy and Google Classroom. If you do Google Classroom, you don't have to give me the hard copy. But you do have to give it to me before class starts here to not count late. Yeah, just go through the site. If you give it to me later today or later this period, it will be counted late. I don't want you to just try to do your homework in class and then miss something else. So y'all need to be on top of that. Now, I also won't say this all year, but for the second time, if you forgot your homework, you should still give me what you have. Take the half credit today. When you get it back, you can finish it and get half of those points back. If you don't give me what you have, then the best you can do is 50% if you do it before the test completed. So it always makes sense to give me what you got and then finish it up again later if you need to. Thank you. Okay, so we've kind of had a little bit of a break here since Friday was an A day, and again, this isn't until Tuesday, so let me do a quick little recap in the 2 days that we saw each other last week. We talked about limits. We talked about what a limit is measuring, what it looks like on the graph on day 1. And we talked about how to deal with 0 over 0 with factoring on day 1. Practice that on day 2. And then the main thing we talked about on day 2 was other ways to deal with 0 over 0, like conjugates, like complex fractions, like trig identities, and then practice a little bit of other stuff. Today, we're going to be looking at 2 different skills. IVT, which is on handout 7. So that is an abbreviation for intermediate value theorem. Calculus has 3 big theorems: mean value theorem, extreme value theorem, and intermediate value theorem. Now, to be fair, this one's probably the least important of those, but it is still a good part of calculus. And then the other thing we'll look at today is limits at infinity. So limit as x approaches infinity, or the limit as x approaches negative infinity. So I'm going to do sum of 7 with you, then sum of 8 with you. Then you'll have some class time to work on those, but then what you don't have finished on those 2 is what you'll need to do for homework. Okay, so extreme value theorem, IVT. IVT is a good abbreviation for that. You can just put IVT on a test and your AP exam. You don't have to spell it out or anything. But to be honest, IVT is it's kind of common sense, and the definition seems a little complicated. So this one's a little bit easier after we do a couple of examples here. So in this little box here, we are going to talk about between some number, a couple x values. We're going to say from x is a to x is b. Some generic number a, some generic number b. So there's going to be a point at a, we'll call that f of a. There will be a point at b, we'll call that f of b. Now, the extreme value theorem, even though this may not seem that important today, only works if this graph is continuous. We're going to go more in depth on what it means to be continuous next class. There's a 3-part definition that you have to remember. For those of you that did pre-cal and those of you that didn't do pre-cal, you'll have to memorize that. But because it's continuous, we can just assume that these are connected. Now, I have no idea if this zigzags a lot before it connects. I don't know if it's a straight connection. So we'll just assume it's something probably pretty basic. We just know that it's connected. Okay, whether f of a is bigger than f of b, or f of a is less than f of b, it doesn't matter if this is increasing or decreasing, there will be a value f of c between f of a and f of b. So somewhere between a and b, there's a value of c, and that value of c has to be between f of a and f of b. Okay, and then for the last part of the definition, and then we'll throw some numbers in there, so I think that will help you see what we're talking about. According to IVT, there's a value c, an x value c, such that f of c is going to equal something. Now that just depends on the question, where c is between a and b. Now, as I said, the definition's kind of long-winded and doesn't seem very intuitive, but let's just throw some numbers in here, and then I think you'll start to see how this works pretty quickly. Let's pretend this point is at, like, I don't know, 2, 3. Let's pretend this point is at 1, I don't know, 7. If c is between 1 and 2, and if this graph is continuous, that's important, because by saying it's continuous guarantees that this graph doesn't start jumping around. There's no like asymptotes that go to infinity. There's no sudden holes in the graph that I don't know about. It's fairly predictable if it's continuous. We don't know what's going on between these, but we know it's connected. All that IVT is saying is that this x value in the center has to hit all of the x values between f of a and f of b. So if this one's down at 3 and this one's down at 7, it has to hit all the y values between 3 and 7 at least once. If it zigzags a lot, it might hit values between 3 and 7 multiple times. It might hit the y value of 4 multiple times. But IVT guarantees that it happens at least once. So IVT happens all the time in the real world. If you guys drove to school, if I asked you what was your top speed and you said 60 miles per hour, I don't have to ask, was there some time during your trip that you did 50 miles per hour? Your car doesn't just magically jump to 60 miles per hour. You had to do 50 miles. Your speed is a continuous thing. So if you were going 60, then at some points you did 50. That's basically what IVT is saying. If at some time the y value was 7 and sometime the y value was 3, then you have to hit all the y values between 3 and 7 at some point. Okay, so some of the questions that they will ask you to practice will be from a table like this. So let's go over this one together, and I'll tell you my approach. Now, you probably want to do a little bit of this at first, and then you probably want to wing yourself off of this. But worst case is you can always give yourself a visual of this table. If you're willing to plot 0, 1, 3, negative 5, 4, 3, 8, 7, and 9, negative 1. You can make a visual of this graph. Now again, it might not seem that important to you, but the directions have to say that it's continuous. So, for all I know, this graph is zigzagging a ton between these points, but since I know it's connected, because it's continuous, at the very least it's got to go down and touch this point, and then touch this point, and then touch this point, and then touch this point. So, if you want to make yourself a visual, just take the 15 seconds and make a visual. So, between 0 and 9, what is the minimum number of zeros? Remember, a 0 is an x-intercept. So this is when y is 0. Right, so with the visual, that takes you no time at all. It has to cross here, 1, here, 2, and here, 3. Now, why does it say minimum? Right, I don't really know what's going on between 0 and 3. So if it's zigzagging a million times, it might be crossing the x-axis a million times. But I don't know that, but I do know it crosses at least 3 times. Okay, from 4 to 9, how many times is y equal 1?
Once.
Very good, just the once. Could be more, but at least once. Okay, number 3, between 0 and 4, must there be a time for x when y equals 2?
Yes.
Okay, so again, if you have your little sketch here, you can graph in the line y equals 2, 0 to 4, he is right there. Okay, so here's what we need to make a habit out of writing. So the answer is yes, but for explain, this is, I would say that as you guys get more familiar with the ARP AP exam, multiple choice questions are not always easy, but they're usually pretty straightforward about what they want you to do. FRQs are the ones where it's harder to get points off of your free response questions, partly because the explanation, sometimes you guys don't explain it well in math terms, sometimes you give too short of an explanation, sometimes you will make a statement that has some counter examples to it. We really have to practice like the bare necessities of what they're expecting here. So what I would expect to see on an FRQ here is you would need to say, well, f is continuous. That means IVT is in play. But you can't just say I'm using IVT without saying why you're using IVT. I'm using IVT because it's continuous. F of 0, this would be the starting y value, was 1. F of 4 was 3. That's the ending y value. So IVT is saying I'm going to hit all the values between 1 and 3. So IVT, again, you don't have to spell out intermediate value, guarantees that we hit all y values of 1 through 3. Sorry, I ran out of space. At least once. When x is between those values. You really need to state that part at the end there. It's not necessarily true from 0 to 1. It's not true from 0 to 2. It was true from 0 to 4. So this is why I can refer to IVT. Actually, I should probably say one more thing. And I know this, again, this is where it's kind of weird. It's like, that's obvious, but like when we grade these, we have to grade them on a rubric. Same thing when they score your AP exam. I was trying to figure out if there was ever a y value of 2. Well, 1 to 3, 2 is bigger than 1 and less than 3. So 2 is trapped between 1 and 3. Again, I know that sounds stupid obvious, but that's what you're trying to say in IVT. You're going to hit all the values from the starting y value to the ending y value, and 2 is in between those.
Do we need to put the 1, 2, 3 part
Yes, yes. You need to show that the one you were looking for is between the start y value and the end y value. So make sure you copy that one down well as an example, so that when you practice some of these on your own, you do one, flip back to this, and make sure you get all that. Continuous, start y value, end y value, say something about IVT, show that your y value is between those numbers, and state when it's happening. You really need to make a habit out of doing that so that that's a little more manageable on a test. Okay, so from 4 to 8, could there be a y value of y equals -2? So here's our graph again. From 4 to 8. Here's 4, here's 8. Could there be a y value of -2?
No, not between those two.
Okay, I heard someone say could.
It could just like dip down super far.
Right, so remember, I only know these 5 exact points. I know it's continuous, so I know they're all connected. But again, this could have zigzagged a million times here, and I can't see that. So could this have gone down to -2 and then back up here?
Yes.
Of course. So could there be? Yes. But IVT does not guarantee it. So IVT is useful for a few things, but it's not magic. It doesn't magically know what's going on. It doesn't have more information about what's going on between 4 and 8 than we do. We know what's happening at 4. We know what's happening at 8. We're not sure what's happening in between other than it hits all the y values between 3 and 7. Okay, and then one more.
T spelled with an N.
Oh, I have no idea. Did I spell this wrong? That's why I'm a math teacher. Usually if I don't know how to spell something, I'll just scribble it. Then y'all write it the way you're supposed to do it. You don't get count off for spelling. So, all right, most IVT questions are going to be more like this question 5 though. Here's some graph, here's some function. We don't know what it looks like. We're not going to get a calculator to see. But does it ever have a y value of 8 during this time? And you should be able to back up your answer. So this is IVT. I want to know, does it hit this y value between those x values? So plugging in -1 is going to tell you the starting y value at 3. Plugging in 5 is going to tell you the ending y value, 21. So if it starts at a y value of 3, it ends at a y value of 21, does that mean it has to hit a y value of 8 between those? Yes, you do. But the only reason you're guaranteed to do that is because this is continuous. Polynomials are always continuous. Without it being continuous, you better not refer to IVT. IVT doesn't work if it's not continuous. If your graph's jumping around all over the place, then we can't make assumptions about what's going on between points. So let's look back at this last one. We needed to say it was continuous. We already found the start y value and end y value. So our explain or justify is we should say IVT guarantees a y value of 8. Got this continuous as 8 is bigger than 3, less than 21 during the time when x is -1 to 5. Now, if you were interested in when that happened, that would just be a regular algebra question. If you want to know when this function equals 8, you could just set this equal to 8 and then solve that quadratic. Subtract the 8 over, solve with factoring or quadratic formula. Okay, let's turn the page here and let's look at one more low group together, but this time I'm going to show you a different approach. So this one, again, I think this is a great strategy at first. Plot the 5 points, connect them, you got a visual, it helps you feel safer about there being 1, 2, 3 zeros when you can count the zeros. But as you move on, you don't really have to do that if you're careful about reading the table. So that's how I'm going to do this one, just to show you some perspective about what you should be aiming for. Okay, from -5 to 1, that's right, just right here, does there have to be a y value of 30? Yes. Starts at 7, goes to 40, and it's a continuous function. So, the easy part is yes. The explain part gets easier with practice. It is continuous. Which puts IVT in play. 30 is bigger than 7, but less than 40. And so we need to say something about IVT guarantees. Now I'm in my head about spelling guarantees. IVT guarantees you will have y values from 7 to 40 when x is negative 5 to 1. You need the when it's happening because it's not true all the time. You need to say something about how 30 is bigger than 7 and less than 40. That's what you're doing in your head. But for those of you that didn't see yes here, notice I really was just focused on this. If it starts at a y value of 7 and ends at a y value of 40, and it has to hit all those y values, it was certainly hitting a y value of 30. You don't have to sketch the picture to be able to figure that out. Okay, between 3 and 8, so that would be focused on this in purple. Between 3 and 8, could there be a value where y is 100? Yes, there could be. We don't know what's happening at point 4 or point 4.1 or point 4.2. It might be shooting up to 100 and then coming back down. So it could be, could is the magic word that changes the answer here. If the word was must, it would be no. IVT guarantees that it must happen, but could, yes, it could happen, but IVT does not guarantee it. I'm going to learn one thing today. Anything could be happening between 3 and 8. It's just not guaranteed to happen. IVT would only guarantee numbers between 21 and 75. Okay, negative 5 to 14, the minimum number of zeros. So notice we're looking at the whole table. Okay, so from negative 5 to 1, does it have to cross the x-axis here?
No.
From 1 to 3, does it have to cross the x-axis?
No.
From 3 to 8, does it have to cross the x-axis?
No.
From 8 to 14, does it have to cross the x-axis?
Yes.
Good. It was above the x-axis, positive y value, to below the x-axis, negative value. If it's crossing the x-axis, whether going above to below or below to above, that's how you're getting a 0. We only know for sure about that 1 0. There's only one time we can promise that it will cross the x-axis. Okay, what's the fewest number of times y will be 20? Okay, so 7 to 40, it's going to have to be 20 at least once. From 40 to 21 doesn't have to be 20. From 21 to 75 doesn't ever have to be 20. And 75 to negative 100 is the second time. There's 2 times in there that it has to have a y value of 20. And again, I don't need the picture for that if I'm looking at the y values and thinking about how they're changing. From 1 to 8, fewest number of times y could be 7. So I'm only focused on this. I think this is a good idea for you guys sometimes too with tables. Just kind of box in what you're looking at, especially if this was a test question, one multiple choice question. Yeah.
On number 4, would it just be 1? Does it say 1 to 14? So it's not counting that.
You're right, yeah. From 1 to 14, I should have only been looking over here. I wasn't paying attention to the full question. Make sure you're, I'm even underlining most of these, but I just did a bad job there. Thank you for catching that. Okay, from 1 to 8, how many times can y be 7? How many times does y have to be 7? 0. We know it's 40. We know it's everything between 40 and 21. And then we know it's everything from 21 to 75. It might be other y values, but we don't know for sure. Well, we do know for sure it hits all the y values between those, which is not 7. So IVT does not guarantee that it would ever hit 7 between 1 and 8.
Your ones look like 2s, look like 1s.
My 2s look like 1s.
The number 4 and number 3 both looks like 1.
Yeah, those are both 1s.
That's not for number 4.
Yeah, for number 4, I did say 2, but I was looking at the whole table. You should have been just looking at 1 to 14. I had a mistake. That's why.
My original answer.
Okay, so you can see that they're going to have you practice a couple more of these table types, and then a couple questions from AP level questions, so you can see what those look like. But before we put this assignment aside for a few minutes, is there anything that's jumping out at you about how to approach these questions, or the conditions for IBT, or how I'm applying it, or what it says? Anything that you want to get cleared up? Okay, then the other notes we're going to look at today, the second half of today's practice, is going to be limits at infinity. So the limit as x approaches infinity, or the limit as x approaches negative infinity. And for the most part, if you remember the 3 horizontal asymptote rules, you pretty much know the math behind this already. So I don't think these notes really review you on the 3 steps for horizontal asymptotes, but we'll go ahead and fill them in. Anytime your denominator grows faster than your numerator, your whole fraction is headed towards 0. Even if your numerator is growing, if your denominator is growing faster, your fraction gets closer and closer to 0. In fact, you could throw some numbers in a calculator and just get just make your denominator grow faster than your numerator, and the more times you do that, the closer you'll see it gets to 0. If they grow equally fast, meaning that the degree of the numerator is the degree of the denominator, this is where your horizontal asymptote comes from leading coefficient over leading coefficient. And when your numerator grows faster than your denominator, then your whole fraction just keeps getting bigger and heads to infinity or negative infinity, depends on the question, depends on if it's negative. The safer play is to just say does not exist. Remember, does not exist is also covers you for infinity or negative infinity. So this is something you do need to know for the ACT. So those of you still doing the ACT or trying to raise your score, you need to make sure you know horizontal asymptote rules. The degree of the denominator is bigger, it's 0. Degree of the numerator is bigger, it doesn't exist. If the degrees are equal, you do leading coefficient over leading coefficient. So one thing we need to do is we need to sometimes figure out how these things grow, like which one grows faster than the other. So let's say that you had one of these as your numerator and maybe one of these as your denominator. You've got to figure out which one's growing faster. So what you could do is like what this person did, is they could plug 1 into each of those to kind of get a starting value, then plug in 10 into each of those to see how fast they're growing, then maybe plug in 100 to see how fast they're growing. But when we look at this data, which one of these looks like it's growing the slowest?
The bottom one, ln x.
All right, natural log of x is the 7th fastest. It's the slowest. Which one of these appears to be growing the quickest?
It would be the 6th one forward to the x.
Right, so the fastest is, there are things actually mathematical that are faster. If you know what factorials are, those grow faster than exponential. And those of you taking BC next year, you'll have to learn about factorials for that. But so then it just depends on the base. 4 is a bigger base than E. E is about 2.7 something, which is a bigger base than 2. Bigger the base is, the quicker it rises, but mostly these grow, you know, all of these grow insanely big. You guys remember how to read this with scientific notation?
Yes.
What's this 301 mean?
There's 301 zeros.
That means you have to move the decimal 301 times. So you can move it once, twice, and then the next 299 would create zeros. So it's a pretty big number. But these are even bigger. Okay, and then stuff like x squared, x cubed, x to the 10th. The bigger your exponent, the faster it's going to rise. The smaller your exponent, the slower it's going to rise. But what I want you to see out of this is, if you don't know which one's bigger or smaller, just try plugging in 1, plug in 10, and sometimes if you see the first few values, you get an idea of how fast those are growing. Okay, we okay there? Okay, so now let's actually use these horizontal asymptote rules. I'm not going to refer to limits too much yet, but that's really what we're building up to. If the degree of the numerator is bigger than the degree of the denominator, this is either going to infinity or negative infinity. If you really want to think about the signs, it's positive over positive, which would be positive. But don't even take the risk to do that. If you think the answer is infinity or negative infinity, just say does not exist. Because if you say negative infinity and the answer is infinity, you missed it. If you say infinity and the answer is negative infinity, you missed it. If you just say does not exist, it can count as either one. Okay, second example, if the degrees are equal, then horizontal asymptote will be y equals leading coefficient over leading coefficient. And then the only other possibility, the degree of the numerator can be bigger, the degrees could be equal, or the degree of the denominator could be bigger, would be y equals 0.
We need to do the y equals, or can we just put the number?
You really should say y equals, because it's a horizontal asymptote, not a vertical asymptote. Y equals gives you vertical or horizontal lines. X equal gives you vertical lines. Now, again, until we get to about question 8, I'm not going to focus on limit stuff. But what I need you to understand is a horizontal asymptote tells you as x gets really big, as x approaches infinity, what y value is it approaching? And as x approaches negative infinity, what y value is it approaching? So horizontal asymptotes are a way to describe the y value at the ends of the graph, which is the same thing in calculus if we were asking what is the limit as x goes to infinity, or if we were asking what's the limit as x goes to negative infinity. If you can do this horizontal asymptote rule, you could do either one of these two calculus problems. They're the same thing. Okay, to look at a couple where they try to twist it up and make it a little bit harder. What do you think the degree of this numerator is?
2.
Okay, but isn't this exponent of 1?
Yeah. It's multiplied by x.
Very good. So you can go ahead and FOIL this mess together if you want to. You're going to have 1x squared plus some x's plus a constant. That stuff doesn't matter with horizontal asymptotes. That stuff becomes insignificant as you start plugging in really big numbers in for x. Okay, what about the denominator? What's the degree of the denominator?
2.
Right, so again, you could do 4x minus 3 times 4x minus 3, and you can go ahead and FOIL the whole thing out. But really, you just need this first part. So you don't actually have to multiply them out, but you better look at it long enough to realize that the degrees are equal. And if you did leading coefficient over leading coefficient, you would get 1/16. X times x is 1x squared. 4x times 4x is 16x squared. So if you want to be lazy and not FOIL those out, that's fine. Just be careful that you're looking at that correctly. Okay, another one, and I'm actually going to throw some limit stuff on this one because these two are pretty similar. There are a few questions where you can't just apply horizontal asymptote rules because, or at least not right away. You can't just look at this and say that the degree is 2 because it's being square rooted. So what you can do is you can say, well, I'm taking the square root of 4x squared and some other stuff, but I really just care about this biggest leading coefficient, and the biggest x with the biggest exponent. So what is the square root of 4x squared? Okay, so it's 2x plus some other stuff that is going to be insignificant. But if you factor that in, now you can see the degree of the numerator is 1, degree of the denominator is 1. So if the question, I would like you to write it out this way on this one, please. If you are asked about the far left of the graph or far right of the graph of y, you should be getting the same thing. Well, or almost the same thing. Degrees are equal, so leading coefficient over leading coefficient. There's only one catch in this question, and that is on this one could be negative. Notice if I plug in a negative infinity down here, if I plug in smaller and smaller numbers, do you see how the denominator is going to be negative something? Okay, the numerator, why does the numerator have to be positive? Right, you can't take the square root of a negative number unless you're doing imaginary number stuff. So this has to be positive, and this is negative in this case. A positive divided by a negative is negative. Down here, if you plug in a positive, this goes to positive infinity, this goes to positive infinity. Positive divided by a positive is positive. So sometimes you need to be careful with the signs. Okay, let's do.
The negative came from the negative infinity.
Correct, yes. Okay, let's look at one more like this. So, you can't exactly do it this way, but you can say the square root of 4x to the 4th plus some other stuff is basically going to be 2x squared plus some other stuff. Again, the other stuff just has no impact on the question, so we don't care about that. So I can see the degree of the numerator is 2, the degree of the denominator is 2. So, the far left of this graph is either going to be 2/3 or negative 2/3, and the far right of this graph is either going to be 2/3 or negative 2/3. When I plug in infinity or negative infinity into the numerator, will that be positive or negative? Always positive. You can't take the square root of something and get something negative. It doesn't happen. So this has to be positive. If I plug in infinity into the denominator, would this be positive or negative? Very good. So positive divided by positive is positive. If I plug negative infinity to the denominator, what happens? How come? Right. Since anything squared is positive, times 3 is positive, and as you get to really big numbers, that -1 does nothing. So positive over positive, that would be positive as well. So sometimes you, again, those are on the trickier side. Sometimes you got to be a little careful there. All right, and then finally the last two, and then I can let you go back to IVT and practice some of that and make sure that that's working out for you. Sometimes you're going to need to not be able to use your horizontal asymptote rules, and you're going to have to do some direct substitution. So you can try to do direct substitution here, and you end up with something that looks like this. And you can do direct substitution over here, and you end up with something that looks like that. So there's not like rules that you can just, well, there's a couple rules you can memorize, I guess, to help you. But you really just need to do kind of function analysis. Think about what's happening here. This fraction, if you take the number 1 and you keep dividing it by bigger and bigger numbers, what is this fraction going to head to? Okay. Now, if I have a number like e and the exponent's getting closer and closer to 0, what does e to the 0 approach? Very good. Anything to the 0 power is 1. So the answer to that, as x gets to be really big, gets closer and closer to -4. Okay, when I did direct substitution on this one, it looks like this. Now, if you were in my pre-calc class, I asked that you memorize this so that you can just make that quick substitution. But if you don't memorize that, you should at the very least remember, because we're going to have to do this a lot in a few weeks, a number that has a negative exponent can move to the other side of a fraction and make it a positive exponent. Negative exponents are generally considered to be unsimplified, so that's why that's going to come up a lot. So this is just an exponent rule. Now, in my denominator, if I have a number, any number, if the exponent just keeps getting bigger, what is this denominator heading towards?
Infinity.
Good. It's just going to keep getting bigger as well. And then for about the third time today, if you have your numerator, if it's not growing faster than your denominator, then what is this all heading towards? 0. So, if you wanted to take the time out to graph this, the further you go to the right, the closer your graph gets to 0. If you wanted to graph this, the further you go to the right, the closer your graph gets to y equals -4. That's what we're figuring out. So it's a mix. It's a mix between applying the horizontal asymptote rules, trickier questions where you need to think about plus or minus and how square root's always positive and take the square root of the first term, and then maybe direct substitution and then try to figure out how it's going. So 2 of the handouts you guys picked up, some of our copy machines staple and some of them don't, so obviously I always try to staple them for you guys, but I don't always have that luxury. So you should notice 2 of your handouts today say 8 page 1 and 8 page 2. Both of these make up assignment 8. And I had you pick up assignment 9, but we didn't have time to get to that in my 8A classes. So assignment 9 you can just put in your binder until next class, unless you're ahead and you want to try it. It is just extra practice. Alright, so with the rest of class, I want us to kind of reset here. I want us to all be on the same thing. So first off, I'd like you to reset and go back to assignment 7, where we were talking about intermediate value theorem. I think you should spend a minute or 2 glancing over the questions and examples we did together at the start of class. Give yourself a quick little reminder. And then try to finish up worksheet 7. And since everybody will be working on worksheet 7, as you get to something that you need help with, there's probably other people that also need help with that question. So just let me know and we can talk about it on the board. Once you're done with worksheet 7, the other one you need to do between now and Thursday is worksheet 8. So when you're done with worksheet 7, you can move on to worksheet 8. But do 7 first, please.
There's 2 pages for number 8. Can we staple them together?
That's up to you. I probably would, but I mean, if they stay in your binder together, and you put your name on both of them.
I mean, it just makes it easier to organize. I mean, when I turn them in, also, they'll be together.
Yep. I will also add that for both of these worksheets, I have the solutions on the website. Now, they're not my solutions, so there may not be a lot of steps shown for some of these. But it is important and necessary and required that you check your answers. So if you want to work a couple questions on this worksheet and then check your answers, that would probably be ideal. If you want to finish all of this worksheet and then check your answers, I guess I'm not upset by that, but if you were doing something wrong, you might have to redo a bunch of it. If you're checking your answers as you go along, you can catch that mistake right away and not have to redo that. So those are on our class website. The website I asked you to bookmark the first day of school. Scroll down to assignment 7. There'll be a link there that says solutions. Click that, it'll pull them up, and you can make sure you're doing it right as you work along. Alright, so until somebody asks a question that I need to address on the board so everybody can hear it, you guys are welcome to work quietly with your neighbors. If one of you wants to check the answers online for both of you as you go along, that's fine. You want to help each other, that's encouraged. But just don't be a distraction to others, and make sure that you pause your conversation if I need to answer something on the board. Okay, is there anything that you found that you'd like me to go over with you from number 7?
Number 20.
Number what?
20.
Number 20? I will. Okay, so number 20 is pretty far down the line here. So again, you guys have some options here. If somebody else is asking about number 20, there's probably a good chance that you might need to know about it as well. So you can either quit what you're doing, jump ahead. You could, I guess you could pull up the class recording and try to find this spot, although that's not very efficient later on. Or I try to record these individual ones as individual videos if we need them. Okay, I already recorded this one yesterday, so I don't need to record it. Okay, so I I don't always use these at the start of the year, by the way, these notes. I have my own set of notes that I've made. But honestly, one of the things I really like about these notes is at the end of these, some of these are giving you some AP level questions, which are much harder, takes much more thought, but that's what you have to adapt to and feel comfortable with before we get to our AP exam. So as I go over question 20, you're going to see that I'm saying the same stuffs about IBT, but they always like to try to put a little twist on it where it's not exactly the same as one that you did 20 times. It makes it really like test to see that you understand what you're doing and not just following the process. Okay, so number 20, this is a continuous function, which means IBT is fair game. I know 1, 7, 7, 1. There, that's at F, and then there's some function G, so two different functions. Explain why there must be a value C between 1 and 7 where G of C equals 0. So we have to show or prove, explain why there has to be a Y value of 0 for C. Well, IBT says test the beginning and the end. So the beginning Y value would be G of 1, and the end Y value would be G of 7. I know IBT is going to tell me I hit everything in between those. Now, if I plug 1 into G, I get F of 1 minus 1. And what is F of 1? Right, that's why they gave it to you. But notice, giving you a whole different function and making you do G is whatever F of X minus 1 is, again, you just don't get to practice that all the time. There's no way I can give you 50 questions of every single type that they can ask you on the AP exam. So we just have to learn to adapt as we see them. All right, G of 7 would be plugging in 7 for X, which is the same thing as F of 7 minus 7. F of 7 is 1, so that's negative 6. So I know it starts at a Y value of 6, ends at a Y value of negative 6. IBT guarantees I'm going to hit everything in between those like 0. So the only other things I would need to state is that even though they said continuous, you should probably say it's continuous. You need to say something about IBT. IBT guarantees we have Y values between 6 and negative 6 from 1 to 7 and 0 is definitely between negative 6 and 6. Okay, so does that answer your question? Okay. Anybody else that knew they needed to ask about 20 need to ask anything while it's up there? Again, the main thing is you have to understand IBT well enough that you can see that that's what they're talking about even without them referring to it. So now this doesn't really apply too much for us on our first two big assessments, but we do tend to try to use released FRQs and released multiple choice questions, which are harder questions like this. So when we do lots of AP questions on one of our quizzes or tests, there usually is a curve that goes with it, because you know, being able to do all AP level questions is a goal for the end of the year, not an expectation on week 2. And then the other thing you may not be aware of, you guys know that you don't have to get above 60% to pass your AP exam. 60% on the calculus exam is like a pretty high 4. So it wouldn't be fair to say you're ready to get a high 4 on the AP exam, but in class you have a 62% or something. So that's why we curve those when that's time. Okay, do we have another question or two I can help with? Still on number 7. Yep.
It's not like yes or no. Can you say like will any of them be not yes and
Will there be any that are not just yes or no?
Yeah, like number 17.
That's a yes or no question. Huh?
Is it yes or no?
Oh, it's a no.
But it could be. It just doesn't have to be.
Well, it says will it be there?
We don't know.
There's no guarantee it will be -1.
So you just say there's no guarantee.
Yeah. IBT does not guarantee it.
I have a question on the wording. If you
Uh-huh.
say like -30 is between 10 and 17, does that work? Or do you have to like write out? So,
That's fine if you also say during the times from 2 to 15 or whatever. Now, technically, if that's stated in the question, you don't have to restate it in your answer, but I think it's a good habit because that's not always obvious. Okay, good questions. Any others that you guys have ready to go from assignment 7? Okay, I'll let you work in peace again for a few minutes. And you guys have about 31 minutes. So again, I want you to try to finish number 7 in class. I'd like you to finish number 8 in class. If you can get both those things done without rushing and still do a good job, then I guess you don't have homework. And how much you don't get to is what you'll need to do for homework. But 31 minutes should get you pretty close. Caroline, is this you?
Yeah, sorry.
This line. there was one homework paper that did not have a name on it. So if I'm done passing out the homework. So if you turned one in and you didn't get it back, you're supposed to know name paper. You need to come claim it for me to know who to give points to. If you want to come look at it, you can. That's you. Okay.
I didn't know this one, it says you got exactly 2 zeros and more than 1 0, which are both true, because having 2 would be more than 1.
You don't know it has exactly 2, because what if it's hitting some others between those points?
Oh yeah, you're right. Thank you.
That's the trick. Okay, offer again. I'll offer for both worksheets this time, but first off, number 7, anybody still on the IBT worksheet have 1 or 2 questions you would like me to go over to help out? Yes, sir. 22, I will. So again, 22 is another one of those AP questions. So this was from a real AP exam. And again, I like these because it shows you kind of what you're trying to do here. It's typically unlike other math classes where it's just like the 50 questions you practice on a worksheet beforehand. This is IBT, but phrased in a different way. Okay, so it's continuous, so that's how I know I can use IBT or refer to IBT if I want to, although most things we do in calculus are going to talk about it being continuous and it won't be IBT. They say we're talking about 0 to 4, and then they give me some points. So I can't visualize these as well as I can visualize a table. So what I'm going to do is I'm going to take that 15 extra seconds and just plot them all. 0, 1 is a point, 1, 2, 2, 0, 3, negative 3, and 4, 3. Okay, now I have a visual. Now remember, we don't know what's going on between these points, but because it's continuous, we know eventually this point's going to connect to this point will connect to this one. All of these are going to be connected at some point. So I'm going to connect them just to give myself a visual, but this is about as straightforward as it could be. Alright, so which one of these has to be true? So choice A. F has exactly 1 0 from 0 to 4. Can you see that that's not true? It does not have 1 0. C. F has more than 2 zeros. Can you see that that's not true now that we did the graph? Okay. Could be B, D, or E, I guess. So D, here's the tricky thing, and this is what they're trying to get you to fall under. F has exactly 2 zeros. Do you see how this looks like it has 2 zeros? You're tempted to say this is the answer, but why is D not correct? Okay. There could be other zeros. IBT guarantees 2. But again, we don't really know what's happening between 0 and 1. If it's zigzagging this way a million times, there could be a million zeros right here. We just can't see that. So the only one that is 100% always true is F has to have more than 1 0. It might have 2, it might have 3, it might have 300. But choice B is the only one that's always true. Okay, anybody else that was going to ask about 22 need something more specific there? So, I'd say if you saw this on a test, consider giving yourself a picture to make it a little bit easier, and then don't just pick the first answer that seems like it makes sense. It looks like this has 2 zeros, but it could have more. IBT can't tell you everything that's going on. It can only tell you stuff that it is 100% sure about. Okay, another question or two from handout 7. Okay, I will try to ask on that one more time before our class is over. All right, I know some of you have moved on to number 8. So has anyone gotten to a question on number 8 that you thought was harder, you'd like to talk about?
12.
Number 12? Sure. Okay, so in question 12, they want us to evaluate this limit, and so they want us to say what y value this function is approaching as x gets infinitely small. That's what we're aiming for. So most of the time, it's a limit as x approaches infinity or negative infinity. You can just apply horizontal asymptote rules. But you can't really do that here because sine doesn't really have a degree. The denominator has a degree of 1, but we don't really say that sine has a degree. It's not a polynomial. So instead, we need to think about direct substitution, try to just plug in negative infinity everywhere there's an x, and then we need to just try to make sense out of what's happening with this fraction. So I guess my first question is, with sine, do you remember what the sine graph looks like? Okay. It's one of the wave type functions, also on the ACT, by the way, so y'all might want to relearn that. But it oscillates, right? It oscillates between 1 and negative 1. So if you go far enough to the left, the further you go to the left, it's just bouncing back and forth between numbers between negative 1 and 1. Okay? Well, regardless of what number you pick between negative 1 and 1, that's pretty static. It's pretty much stuck still, whereas this keeps getting bigger. So what happens when your denominator is growing faster than your numerator? It approaches 0. And now the numerator could be positive or negative. The denominator could be negative, but 0 and negative 0 are the same thing. So they're looking for 0 there. The numerator basically stays the same. It bounces back and forth between negative and 1, but the denominator grows infinitely big, so that makes that whole fraction head towards 0. Okay, others from worksheet 8 that you know you need help on? Yes.
So for 14, what would we put?
Okay, so 14 is kind of the same idea. Again, you really need to know what the sine graph looks like for some of this stuff. But sine oscillates between 1 and negative 1, and then it just keeps going. So the further you go to the right, the more it just keeps going back and forth between 1 and negative 1. If you keep going to the right, it keeps bouncing back and forth. So it's never going to approach a single y value. So for that, we would say does not exist. It's that y value is always, it's going to be approaching something different the bigger y gets, so, or x gets. Okay, more from assignment 8. Okay, let me give you a few more minutes, about 5 minutes or so, and I'll try to take a couple more questions before time's up. Yeah.
Will assignment 8 answers be posted as well?
Are they not?
Oh, I haven't checked.
They should. They look like they are on my screen.
Cool.
as like amplitude, or would it be like?
Yeah, you could do, I mean, it changes the amplitude, but what does that have to do with the y value it approaches?
Wouldn't. I mean, it would still be two different y values. Because.
Okay, if we plug in infinity in here, what's 1 over infinity go to?
0.
Okay. What does the cosine of 0 go to?
1.
So your answer is negative 3 times 1.
Thank you.
Does 12 not exist?
12 was 0. I'll have it on the website if you want to watch it later, but we already went over it.
And 14 does not exist?
That's correct. Okay, I want to give one more chance for anything from assignment 7. Anything else I can help with on assignment 7?
Does 15 does not exist?
I'm on assignment 7 right now.
Oh.
The solutions are on the website, so you can pull them up on the Chromebook if you want to check them all. You should check them all eventually, but if you want to check them as you go, you need to click them. Okay, so we've got about 8 minutes here, so let me let you know where you need to be with about our 8 minutes. So number 7 and 8, you should finish both of these. You should try all of them. Number 7, I think you've had enough time to get all your questions answered, so I will not be taking questions on this one on Thursday. Assignment 7, if you had questions, you needed to ask them. Assignment 8, it sounds like you might still get to a couple questions and you're just running out of class time. So one thing we'll do on Thursday is I will let you ask a couple of questions from assignment 8 that you didn't have time to get to today, but not number 7. So for your homework, make sure you finish up 7 and 8, have both of those ready to turn in, and on assignment 8, make sure that you know which questions you want some help on before I ask you to turn them in. Any questions about the homework? Okay, you're welcome to keep working on that with your last 8 minutes here, but I do have another puzzle for you. I say another, I don't remember if I showed you all the first one. Did we do the clock one?
Yeah, but we never got an answer.
I posted the answer in Google Classroom. If you want to know how to figure it up and why it's the answer that it is, that's what I would recommend. Did anybody watch the video for that one?
I don't see the solutions for the trig functions horizontal asymptotes in the classroom. It's just this part and below.
Okay, I'll come look at them in just a minute then. Okay, so we already did this one. Anybody watch the video to see what the answer was? Or did I tell you the answer? First answer is 22. So if you want to know why, you have to watch the video. Okay, did I give you this one? Okay, so if you're interested in doing, again, you're welcome to just keep working on your homework, but with about 6 minutes left, if you'd rather put some thought into this, I'll tell you the answer before time's up, before y'all leave, because I would guess that most of you guys would make an educated guess here, an estimate, but there is a way to figure it up mathematically and to do it much quicker than to just doing it manually, so we'll see if anybody can get it. Of course, you can't cheat. Don't search on Google or anything.
Out of 64, then I noticed that there's more squares than that.
There's more than 64.
Yeah.
64 is the number of 1 by 1 squares. There's bigger squares too. The whole thing is a square. So there's another one. What you got? Oh yeah.
So, as affinity is affinity, and then just affinity times this would be this.
Right. It'd be infinity, which is really the same thing.
Yeah.
And then we check the others on the board. Anybody got a educated guess?
Is it 71?
It's not 71.
A whole lot.
Okay, well, what's a whole lot? A whole lot's different to different people. A whole lot of pennies isn't much, but
Is it 83?
it's more than 83.
Got it in thousands.
More than 94. Well, how many 1 by 1 blocks are there?
64.
Okay, so there's 64 as a baseline. How many 2 by 2 squares are there?
A lot. 16.
Okay. How many 3 by 3 squares are there?
There's more than 16 2 by 2.
I didn't say there were 16 2 by 2s. That's what y'all said. I don't know. I'm just trying to get you to think in the right direction. Somebody in my first period class is a BC class. I showed this to them at the end of last week, I think, and a couple students figured out they did it manually and counted it up exactly, but they did it for rectangles, not squares. So that's what they get for not reading the question very carefully. Okay, we got about 3 minutes, so I'm going to tell you the answer in just a minute, but that way people still want to make an educated guess can. And like I've done in the past, if you're interested in the mathematical approach on how could I answer this quickly, I will post a YouTube link in Google Classroom for those of you interested. I think it's a pretty short one. Okay, we're only down to about 2 minutes. Anybody else have a guess?
I'm calculating it. I'm calculating it.
Very good. 204 was the answer. 204 squares.